Hey everyone, today I'm going to be demonstrating the ability to connect Chroma's 63800 single-phase AC loads in parallel for both single-phase and three-phase applications. For this demonstration, I'm going to be using three 63800 AC loads as well as the Chroma 61509 three-phase AC source. To use these units in master-slave mode, we use the provided system bus cables and terminal resistors. These cables supply a sync signal to coordinate turn-on and turn-off, as well as load changes in order to prevent the loads from becoming desynchronized. For a single-phase configuration, we'll connect all the loads in parallel to a single phase on the power supply's AC output. All the units will also share a common neutral connection. Since these units are all parallel to the same phase, they all share the same phase designation, which is A. Within each phase, the units are numbered. 1 is the master unit, and 2 and 3 are the slave units. To demonstrate this setup, I'm using the Chroma soft panel program for the 63800 AC loads, which is on the left, and an oscilloscope, which is monitoring the current for each individual load on a separate channel. These units are connected in parallel to a single phase, so the current will be split equally among the units. First, we'll set a maximum peak current allowance, and then we set a current level. The units are synchronized, so they all turn on simultaneously. We can also change the load level while the loads are running. We can also change the crest factor, which is the skinniness of the wave, and the power factor, which is the angle between the voltage and the current. Next, we'll set up the loads in three-phase mode. For three-phase mode, each of the loads is connected to a separate phase of the AC source. They all still share a common neutral. The sync cables are set up in the same way, but the loads are configured differently. The loads are connected to different phases, A, B, and C. Each phase only has one load connected. In three-phase mode, each load turns on at its own phase's zero crossing. Load changes, however, happen simultaneously for all the phases. We can also change the crest factor and power factor in three-phase mode. In addition to constant current mode, the loads can also be set in constant resistance, constant power, or RLC mode. Each phase's load level, crest factor, and power factor can be set individually for unbalanced loading. In this example, I'll set phase A to 3 amps, phase B to 5 amps, and phase C to 3.5 amps. Finally, for setups outside of single and three-phase, the loads can be set up to run independently on different phases and not interact with each other. In this setup, we've connected load 1 to the first phase, and we've paralleled loads 2 and 3 to the second phase to create unbalanced loading. As before, all the loads share a common neutral. In this configuration, the first load is going to be run independently, so we've removed the communication cables. The second two loads will be a new phase, which is designated Phase A, and they will be numbered 1 and 2. In this setup, we have more than one master unit, so the loads will be used manually. Because the loads are unbalanced, the first load will take all of the current that we set, while the second one will split the set current between the two loads. In this example, we set 6 amps to each phase, but the waveforms of loads 2 and 3 are half the size of loads 1. Since the loads are running independently, we can change the load level and even the crest factor of the second phase without affecting the first. That's all for this demonstration. Be sure to subscribe to be notified when we come out with new products or new demonstrations. Check our website and get a sales quote at chromausa.com. Thanks for watching.